So, we started with a very interesting problem where we had electric field and magnetic field perpendicular to each other, and then a charged particle was released from somewhere, no velocity, nothing, we just placed it and released. And then because of the electric field, the charged particle started moving, and once it started moving, the magnetic force was also operative, Q V cross B. And then we discussed the entire story, that how that path of the particle can be obtained as if, or position of the particle can be obtained as a function of time. And in this process we discovered new things, that if we change to another frame which is moving with respect to the initial one, lab frame, with a velocity E by B, electric field magnitude divided by magnetic field magnitude, and it is moving in the direction of E cross B, right. We took E in one direction, then B in another direction, E in y direction, B in z direction, and this frame was moving in x direction. So, it is E vector cross B vector, that is the direction, that is the direction. So, if you go in that frame, the electric field vanishes, there is no electric field, and it is only the magnetic field, and in that magnetic field the particle goes in a circular path in that S prime frame. Then we simply came back to S frame and then wrote our equations. So, all those calculations we did, and finally we found that in the lab frame, as a function of time, the position x and y is given by these equations. Now, it was to analyze what kind of shape is this, how the particle is moving as a function of time. So, that we wanted to do, and then we did some qualitative work, and we found that okay, the particle must start like this, electric field will pull it in this direction. So, it will gain the velocity as it goes up in y direction in this figure, and then it has to turn somewhere, and then it will touch this x axis again, and then perhaps it will go this way. So, qualitatively we could get this kind of picture, but then what happens here, what happens to the slope, how fast it is going here, how fast it is turning here, how fast it is turning here. So, that slope is something which we should calculate to get the character of this curve. So, that is the task I am starting now. With this I want to get dy dx, and that will tell me something about this. All right. So, from here let us differentiate, we write dx. So, dx will be equal to V naught by omega. So, V naught by omega, and then omega t, differentiate, it will be omega dt, then minus sine omega t, differentiate, omega cos omega t. So, minus omega cos omega t dt, and similarly dy. So, dy is equal to V naught by omega, V naught by omega, and then 1 you differentiate, it is 0, minus of cos you differentiate, it will be sine. So, omega here and sine omega t and dt. So, dy dx is dy dx is dy is here, dx is here, and therefore, this cancels out, this omega cancels out, dt cancels out. So, it is sine omega t and divided by 1 minus cos omega t. Now, this we are looking at this point where this curve again comes to x axis. That means here y equal to 0, and y equal to 0 means cos omega t is 1, and cos omega t is equal to 1 that means omega t is equal to 0, but that is yes, omega y is 0 here, t equal to 0, t equal to 0, y is equal to 0. Next time y equal to 0, we are interested in this point. So, this is 2 pi and omega t should be equal to 2 pi. So, here this y will again be 0, because at this cos omega t will be 1 and 1 minus 1 will be 0. So, it is here. So, omega t is 2 pi. Let us put it here, omega t equal to 2 pi, sine of omega t, sine of 2 pi is 0, cos of omega t 1, cos of 2 pi is 1, 1 minus 1 again 0. So, it is 0 by 0, and hence we should go for the limit. Okay. And we can factorize, we can write this as 2 sine omega t by 2 cos omega t by 2 here, and 1 minus cos omega t is 2 sine square omega t by 2, and you can cancel 1 sine omega t by 2, you can cancel this 2, and you get cos of omega t by 2 and divided by cos of sine of omega t by 2. And remember, omega t by 2 is going to pi, omega t is going to 2 pi in this limit, and here it is omega t by 2. So, that is going pi. What is cos omega t by 2? Cos omega t by 2 here is cos of pi, which is minus 1. And what is sine of omega t by 2? Sine of omega t by 2 is sine of pi, and that is 0. That is 0. So, it is infinity. The slope is becoming infinity, and slope becoming infinity is not a uncommon thing, because if you have a curve, for example, let us say circle, this, you have a circle, okay, this is your x axis, this is the y axis, and some radius. So, at this point, if you ask at this point what is the slope, it is meeting this x axis perpendicularly here, it is semicircle now, this part is semicircle. So, here the angle is 90 degree, this angle, here the angle is 90 degree. So, the slope will be infinity. Slope becoming infinity is not very uncommon. But the interesting thing is this 0, this omega t by 2 going to pi, we can go to pi from left, that means omega t by 2 is always less than pi, and then it is going towards pi. This is one way. We write it omega t by 2 goes to pi, and we put a minus sign here. From negative side it is going, from negative side it is going. What happens then? What happens then to this sign? Suppose you have sin x, suppose you have sin theta, and I say that theta is pi minus epsilon, and this epsilon is going to 0, and therefore theta is going to pi. What happens to sin theta? So, if you see sine of pi minus something, so this is pi and then minus something, this will be the thing. It is like this, and as this epsilon goes to 0, this is that epsilon angle, as this epsilon goes to 0, this side will go to 0, and therefore the sine of this theta, which is this side divided by this, is going to 0, but always it is positive, always it is positive. It becomes smaller, this becomes smaller and smaller and smaller and smaller as epsilon tends to 0, as theta tends to pi. Okay, this epsilon tends to 0 and theta tends to pi, but from the negative side, from the left side. This is becoming 0, but all the time it is positive. What if I say that theta is pi plus epsilon? Pi plus epsilon, epsilon is a positive quantity, epsilon is a positive quantity, pi is more than pi, theta is all the time more than pi, but then we are bringing it towards pi. So what happens? Again draw the figure. This is pi and plus epsilon. So it is this, it is like this, here is the epsilon. What is the sign of this? Sign of this is this side divided by this side. As epsilon goes to 0, this side will shrink, this side will go to 0 and sign will be 0. That's fine. Sin theta is going to 0 whether you come from the left, whether you come from the right. Once you are approaching pi, the sin theta is approaching 0. But in this case, all the time sin theta is negative. It is going to 0, but all the time it is negative. So keep this in mind. This is sine of omega t by 2. Omega t by 2 is going to pi. So if I am coming from left, that means this is the point I am looking for. I am coming from this side and seeing what happens to the slope, what happens to the slope, what happens to the slope. All the time this is positive, this is approaching 0, but it is positive, this is minus, so it will be a huge negative, it will be minus infinity. This will be minus infinity. dy dx is minus infinity, that means it is going down and hitting the x axis. It is going down and hitting the x axis 90 degree. At 90 degree, because the slope is infinity. So our curve should be of this type. So it hits at 90 degree. Our particle should go in on this path. Our particle should go in this path, and it is hitting here at 90 degrees. Remember, y is never negative. Okay, because y is 1 minus cos omega t will never become more than 1. Here it is 1, and again it will decrease from the 1, and therefore this will again rise. Same point, if I approach from right, so omega t by 2 goes to pi, but from the right side, that means all the time this is more than pi, and then it is becoming pi. This picture, it's all the time more than pi, and then it is becoming pi. Again it is going to 0, but it is all the time negative. So it's decreasing, going towards 0, but then all the time negative, and hence this is all the time negative, this is all the time negative, this is all the time negative, and this is minus 1, and therefore it is going to plus infinity. And going to plus infinity means something of this sort. This is the tangent, here this is the tangent, here this is the tangent, this is plus infinity, this is minus infinity. Slope is positive, slope is negative. So that means it will hit it perpendicularly, and then it will rise from here perpendicularly, and the cycle will continue. So you have a cusp here, Of course, here I have started the motion here, but here you can very easily see that it is making a sharp cusp here. So that's the kind of graph, that's the kind of path you can expect. It is known as cycloid. The name of this kind of path is cycloid. So let me draw the graph on on a computer screen, and then we will exactly see how it looks like. So, Desmos is the software that we will be using, excellent software for plotting graphs, etc. And we will plot this graph, and there we need numbers for plotting a graph. Actually plotting a graph we need numbers. So, this is constant, we can take it as 1, this is constant, we can take it as 1. Instead of t, we can write omega t also. Not that I am taking omega equal to 1, but if you plot t or you plot omega t, it is only scale difference. So, we can use these parametric equations and plot a graph between y and x using these equations and see the shape of the graph. So, I will do that on computer. So, this is the Desmos.com calculator, and it gives graph here, and the equation is to be written here. Ours is parametric equation. So, we will be writing it in parenthesis. The x is v naught by omega, we are taking 1, and it will be omega t, which is our parameter. So, we will write it t. So, t minus sin t. So, it is essentially t minus sine of t, comma, this is x. And what is y? Y is 1 minus cos t. So, 1 minus cos of t bracket close, and let us vary this t from 0 to 50. So, this is the graph. This is the graph, you can see. Let me zoom it in y direction. So, y axis I do not need negative at the moment. So, we can start with some negative 1 or so, and then here it is up to 2. So, let me go up to say 2.5, 2.5. So, this is the kind, or let us take it 3. Let us take it 3. So, look at the graph, this is y versus x, right. So, you start from here, then you go, this is omega t, and here you have 2 pi, is about 6.28, pi is 3.14. So, you can see that this is 0, this is 10, and 1, 2, 3, 4, 5. So, each division is 2 units. So, 2, 4, 6, and you can see that it is 6.28. So, at 2 pi it sharply comes at 90 degree to the x axis, then goes up at 90 degrees, and this cycle repeats. So, this is our cycloid path. If the charged particle is released from origin, and if you have electric field in the y direction, that is this direction, and the magnetic field is coming out of this, it is in z direction, then this charged particle which is released from rest will go on this path like this. Okay, so that is it. So, in this example we had taken our charged particle in crossed electric and magnetic field with a 0 initial velocity. We released it from rest at the origin, and then under the effect of electric and magnetic field it goes in a cycloid kind of path. Now, the next will be that we will give it a small velocity in the x direction perpendicular to that E and B direction, and then see how the nature of path changes. So, our situation now is that in the lap frame, this is x axis, this is y axis, and I have an electric field here, and then in z direction I have a magnetic field, and at t equal to 0 this charged particle has a velocity. So, at t equal to 0, this charged particle has a velocity, and let us say it is e by 2b, half of v naught. Remember, e is given to us, b is given to us. So, e by b is a fixed number, it is a fixed constant, and half this velocity we are giving to the particle at t equal to 0, and then trying to see what happens under the electric and magnetic field. So, once again the same trick, we go to S prime frame, and in this S prime frame, which is moving with respect to S at a velocity of v naught. V naught is just E by B with this velocity, because this is the frame in which the electric field goes to 0. So, in this frame we go, and we know that in this frame there is no electric field, you only have magnetic field in z direction, and that is B, this is z direction, this is x direction, and this is y direction. And what is the initial velocity of the particle in S prime frame? So, at t equal to 0, the velocity of the particle in S frame, it is this much. In S frame it is, oh, this is not 2 V naught, this is V naught by 2. E by B is our V naught, so it is V naught by 2. So, in S frame it is V naught by 2 in the positive x direction, and in S prime frame, which itself is moving at a velocity of V naught, if you see from this frame, you find that this particle is going towards left with a velocity V naught minus V naught by 2, that is V naught by 2. So, this velocity is, so position is okay, the velocity is minus V naught by 2 I cap at t equal to 0. Position is of course 0. Position at t equal to 0 is x is equal to 0 and y equal to 0, and of course z is equal to 0. There is no motion in z direction anyway. Okay, so the initial velocity of the particle is minus V naught by 2 I cap. The particle is going in this direction with velocity V naught by 2. So, what is the scenario? You do not have any electric field, you only have magnetic field, and that is in z direction, and the initial velocity is perpendicular to that, and therefore, it will go in a circular path perpendicular to the magnetic field, that means in xy plane. What is the direction of the force? What is the direction of the force? V B is equal to Q times V cross B. Initially at t equal to 0, V is this way, magnetic field is this way. So, you have a V naught V cross B, that will be in y direction. So, it will bend like this and it will go in a circular path. That is the motion in S prime, very simple, just a constant magnetic field and particle projected perpendicular to the magnetic field. So, it goes in a circle. You only have to work out whether it is this circle or it is this circle. So, for that we see the direction of the force, and then in the direction of the force there is a bending, and hence it goes like this. And the angular velocity is q b by m. That does not depend on the initial velocity that you have given, it is just q b by m, that is angular velocity. That means, if this is the center and this is the initial position here, and then the particle reaches here at time t, then this angle is omega t. The angle which the radius is making is changing at the rate omega. So, that is angular velocity. So, this is omega t. Once again you write what is x and what is y. This is x, this is x. So, x is equal to Okay, what is the radius? What is the radius? The radius is given by, the equation is mv by qb. For the radius of the circle we had done it. So, this is mass times velocity, and velocity is now v naught by 2. So, it is v naught here and 2 here. So, that is the radius. With this radius it is going this way. So, this is the radius. How much is this? This is omega t angle, this is r. So, this will be r sin omega t. So, x is minus r sin omega t, and r is this one, and as we did earlier, we can write this r as this q by b, qb by m is omega. So, this is v naught by 2 omega. So, it is v naught by 2, right, this is v naught by 2, and then this is omega here, this is omega here, and then sin omega t. This is x prime in this frame, primed frame. So, this is x prime, and what is y prime? At time t, what is the y coordinate? This is 0, this is origin, this is y coordinate. At time t, the particle is here. So, the y coordinate is this much positive, and how much is this? This whole thing is capital R, and minus this, which is r cos omega t. So, it is r and minus r cos omega t. The same thing that we had done in the previous case where the particle was released from rest, we did the very similar algebra. So, this is equal to r common 1 minus cos omega t, and r as we did here, it is v naught by 2 omega and 1 minus cos omega t. Now, come back to S prime. As S prime is moving in positive x direction with a constant velocity v naught, here this S prime is moving with a constant velocity v naught in positive x direction. So, your x will be equal to x prime plus v naught t. At t equal to 0, this whole thing is here, the origin is coinciding and everything. So, at t equal to 0, x and x prime are both 0. After that, the frame moves at sin from S, the frame moves with certain speed, and at time t, this will be v naught t. Alright, and therefore, if from this frame the particle is here and the coordinate is x prime, then this x from here, this is x, this x will be this v naught t and then plus this x prime. So, x is x prime plus v naught t, and that means it is this is x prime and plus v naught t. So, it is v naught t and minus v naught by 2 omega and then sin omega t. This is x prime, this is x prime. So, this is that x prime, and then we are putting this v naught t here minus v naught 2 omega sin omega t. This is x, and y it's same as y prime. So, it is v naught by 2 omega and then 1 minus cos omega t. This you can write as v naught divided by omega here and omega here, and this v naught by 2 omega you can take common. So, what is x finally? Finally, we take v naught by 2 omega common, v naught by 2 omega common, and then here it will be 2 times omega t. V naught by 2 omega is common. So, 2 omega t. So, it is 2 omega t. Then minus v naught by 2 omega is already written here. So, it is sin omega t. And y is equal to, V naught by 2 omega and then 1 minus cos omega t. This is the equation of the path. At time t, you have gotten the position, x position, y position. So, you know where the particle is, and this gives you position as a function of time, and then you can plot y versus x. T is a parameter, and you can get what is the kind of curve. So, let me once again show this curve on the Desmos. And for that, we will take this V naught by 2 omega, which is a constant. We will take it 1 for Desmos. We have to give numbers there. And omega t, we will use omega t as the x scale. So, for the Desmos, what I will write, x equal to, this is 1, then this is 2t. This t represents omega t, and then minus sin omega t, 2t minus sin omega t, and y will be 1 minus cos omega t. So, let us go to Desmos. So, this is the old graph when our initial velocity was 0, and now let us change. We want to make it 2t minus sin omega t here, 2t minus sin t, in fact 2t minus sin t and 1 minus cos t. So, only thing I have to do is this t becomes 2t. This t becomes 2t, and see the change in the graph, see the change in the pattern. You are now getting a smoothly changing curve, no cusp here. It is not meeting at 90 degree downward and then minus and then 90 degree upwards. There is nothing like that. It is smoothly coming, and then there is a minimum here, and then it goes here, and so on. If you take more time, you will have the same loop several times. This was 50, let us make it 100 t, 100, and then it will be like this. So, you can of course adjust all your x axis and all that, and you can see the loops, So, that is the kind of change you get when you give a small velocity to the particle. So, we will continue with this. We had taken 0 velocity, we had taken V naught by 2. Next day we will take V naught velocity and then 2 V naught velocity, and that will complete the spectrum.